So I challenged myself. Can someone with just 1 week of coding experience build the game Snake? This is only my second project so far. The first one was a calculator, and after I finished it, I thought I was ready for something bigger. I thought Snake would be relatively easy. I couldn't have been more wrong. Over the past few days, I've been struggling with things like game loops, collision detection, keyboard inputs, and lists. So in this video, I show you exactly how far I got, what mistakes I made, and what I learned along the way. And if you want to join my journey from complete beginner to employed developer, consider subscribing. But for now, let's get into the video. Okay, welcome to my next project that I'm doing. The thing is, I have learned something called, or I have learned about a concept called for loops. And they basically go through, let's say, for E or I in range 5, print I. If I do it like this, then it will print me every number. What I thought, if I'm able to print out the numbers going down like this, why can't I use that to print a field that we could use to put an object in that can move around the field, like Snake? Now I'm skipping forward a little bit, but generally my idea worked. By looping through the width and the height of the field, I was able to print a simple game board into the console. At first, I actually got stuck on something much simpler than I expected. My first idea was to do something like field equals to the string of a dot inside the loop. The problem was that every iteration would simply replace the previous value. So instead of building a row like, it would only end up with a single dot. What I eventually learned is that I don't want to replace the contents of a field, I want to add to it. And that's why the line is so important. The plus equals operator basically means take whatever is already stored in field and append it to the next character to it. And after the inner loop was finished, I print the complete row now. The next challenge was to figure out how to place the X somewhere inside the field. For that I created two variables, position 1 and position 2. These variables represent the position of the player. Then every time the loop visits a cell, I check if check is equal to position 1 and I equal to position 2. When I first wrote this, it felt a bit confusing, but the logic is actually pretty simple. The loop is basically visiting every position on the board one by one. So I'm asking, is the current position equal to the player's position? If the answer is yes, I print the X into the field. Otherwise, I just print a dot. As a result, every cell becomes a dot, except for the one position where the coordinates match. That's why the output looks something like this. At this point, I finally had something that felt like the beginning of a game. And now it was time to put this whole thing in a while loop. Let's say we say run equals true, and then while run equals to true. And now we have to put this all here. It should give us this. So in this case, if I print this, it should just overall print it again and again and again and again to the console. Let's see. Yep, I think I've created a monster. After getting the field to render continuously in a while loop, it was time to make the X move. To do that, I asked the user for an input. The idea was simple. W moves up, A left, S down, and D right. Then I used a few simple conditions to update the position. For example, if move equals to D, position 1 plus equals 1. This means if the user presses D, increase the position of X by 1. Moving left works the same, just in the opposite direction. And for moving up and down, I did the same thing, but with the position 2. At first I found it a little strange that moving up means subtracting 1. But since the field is printed from top to bottom, smaller row numbers are actually higher on the screen. The cool thing is that I never directly move the X, I only change the value of position 1 and position 2, and because the field is getting redrawn every loop, the X is automatically appearing in the new position. And although this technically worked to move the X by using the inputs that I provided, it always printed a new field into the console, and I couldn't find a way to actually fix that. So I posted on my YouTube, I posted on Reddit, and I asked a friend of mine who is a bit more experienced in programming, and we actually came up with something. But before I show you that, let me show you what it looked like before I fixed it. Let's try this again. And yeah, it works. So it actually works. It works into all directions. At least the inputs work into all directions. If we press A, it moves to the left. If we press D, it moves to the right. If we press W, it moves up. And if we press S, it moves down. Okay, yeah, we got the inputs working. I learned that the input function blocks the program until an input is made, which is why I'm not able to make the move continuously since it blocks the while loop. But there is an alternative called MSVCRT, which is a Python module. I've never heard anything about modules before, but it is basically a toolbox which contains functions that help you do specific things. In this case, MSVCRT gives us tools to work with keyboard inputs in the Windows terminal. One function from this module is kbhit, which stands for keyboard hit. It checks if a key has been pressed, and the important part is it does not stop the program and waits. It only checks quickly and then the program continues. So in my loop I can write this. This means if the user presses a key, then do something. Then I use the line move equals to msvcrt.getch.decode, and then it has a string utf8.lower. Let's break this down very simply. So first of all, msvcrt.getch basically reads what has been pressed. For example, if I press D on the keyboard, the value returns to me. But it doesn't return as the normal Python string D, it returns as something like this. This is not a normal string yet, so I use .decode utf8, which converts this value into a normal text. Using the decode utf8, which is basically a table that converts bytes into normal strings, I can return the value as a normal string. After that I use lower, which basically converts the letter into lowercase, so if I press the uppercase D by accident, it still becomes a lowercase d. Finally, the result is stored in a variable move. So the full line is basically that I read the pressed key, convert it into normal text, make it lowercase, and then save it as a current movement direction. This solves a problem because my program now is no longer waiting for an input. It keeps running and only changes the direction when a new key has been pressed. If no key is pressed, the old direction stays saved in the move, so the character keeps moving continuously. And here's how I implemented it. We first move the input to a global variable instead of in the while loop. Hoppala. So let's delete it quickly. And then we put move on top of the while loop and equal it to the first starting direction, which is D. After that, instead of the input that we had before, we write this. If msvcrt.kbhit, then we change the variable move to msvcrt.getch, and then we decode it into utf8, and we put it into lowercase like this. Okay, first now we have to import the module itself. On the very top, import msvcrt. Alright, I found out that the field was a bit too small, but the code itself was actually working. So after fixing the field size, this is what happened. And now that we have figured out a way to actually input something into our program without it stopping, I had to figure out a way to actually clear the screen. And this can be done by being able to, as we know, there is this clear screen function which clears the terminal, and we can actually import that into the code by first importing OS, which stands for operating system. And then at the beginning of our while loop, we type in os.system and then as a string cls for clear screen. Basically what this import allows us to do is to use Windows commands within our code. So this means that each time this while loop starts anew, it will clear the terminal, which would result in this not going down all the time. So let's try it first without. But before that, we also have to add in a sleep timer, which basically gives us the ability to wait before the while loop is being used again by importing time, import time. And in the end, we can put time.sleep and set it to delay execution for a given number of seconds. Okay, by seconds. So let's put in like something like 0.2. And this basically allows us to run the code in a more human time sequence. Without it, it would just like run instantly, basically. Like every time it loops, before it loops again, it waits for 0.2 seconds. Actually, let's put it into 0.3 seconds. And yeah, okay, let's first run the program without clearing. Okay, we basically, okay, let's save it one time. Let's run the program. As you see, it moves automatically because we have set the starting direction to D, which increases the position 1 by 1. Now it's off the screen already, but each time it creates a new screen. I don't know if you can tell, but I'm scrolling, right? And each time I'm like you can see, it creates a new screen. We didn't want that. So let's stop the program, let's clear it and put back in the os.systems clear screen function. And now it should automatically, clear the screen. So we only have one screen, and because we can check for inputs while we are running the while loop and not blocking the while loop, we can actually, if everything works correctly, yeah, it works. I'm pressing the keys on the keyboard and as you see, the X moves. This is so cool. Oh my god, I love this. This is amazing. Holy crap. Oh my god, this is so much fun actually. Now it was time for some collision detection. So basically what I wanted to do is check whether or not the snake is actually hitting the borders, and if it does, the while loop should stop and it should print out a loose screen. So here's how I did it. And also how I struggled. Okay, wait, I have an idea. What if we create a variable, let's call it border, and equal it to position 1 is equal to the index 0. Okay, I think we have to put it in brackets. So this should mean that if position 1 is equal to the index 0, which is where our field is starting to be printed, then this variable should turn true, right? Okay, let's try this. We have to, okay, wait. So basically we have to put in another if statement here and say border equals to true. We can, like, let's say we print you lost and set run to false, which should stop the while loop we are having here, right? Okay, let's check if this works. So basically if the position 1 is hitting the ball, okay, wait, where is the problem? Invalid syntax. Ah, okay, yeah, true. It's equal to 0. It's not 0, okay. Okay. It's not working. Am I missing something? Is this not correctly detecting whether or not we like the index equals to the position of the x. That's the only explanation I could have. And yeah, by the way, I think we should also, for the future, implement that we cannot go into the direction where we just came from, as you can see, because that's not a function we would just basically run into ourselves. Wait, let me try something else. Let's say maybe we don't need to create a variable, but we can just put it into an if statement. So if position 1 equals to 0, then we can print this. Maybe this works. Yeah, it works! Okay. But why? Okay, it works. It stopped the program. It gives us the you lost print. Now we have to figure out a way to do it for the other sides as well. I mean, this works. This is nice. Yeah, this is actually cool. Okay, I mean, there is an issue. We are in the second leftist, or whatever you call it, position, and the game is stopped, and it should stop here. Let's fix that first. Maybe if we put this to smaller, then maybe it works. Okay, let's go back. No, it still doesn't work. I mean, why did I think it would work like this? Okay, this is tricky. This position is the index 0, and this is the index 1. Right? So we can't be smaller than the index 0. Wait. What if we do it like this? I mean, I'm not logicking right now. I'm just... Yeah, I mean, it worked! I don't even understand why. I don't understand why it worked, but it worked. Oh my god, this is so cool. So wait, so basically we could put in other logical operators, right? So the first index is always 0. We know that. But if we clear, okay, let's first clear. Okay, I'm getting too excited. If we say that this, or let's say position 1 is smaller than height, then I mean smaller than height. What my logic is that the height is a set variable, which is 25. So instead of going, oh no, I don't think it works like that. Because then it would just immediately stop it, because we're always smaller than this, right? I mean, yeah, let's give it a try. Yeah, it immediately stops, because we're always smaller than this index that we have right here. Okay, maybe we need to put it to bigger. Let's clear, and let's start the program again. Okay, so if we go up, it doesn't work. But if you hit the other side... Yeah, okay, but it goes outside of the bounds here. Okay, this is a bit confusing. Wait. Okay, I know I'm trying a lot back and forth, but I have to check something. So basically here, we are on the border, as you can see. Clear screen, but with the other side equal here. And try it again. Let's clear the screen. Maybe this works, because now we have the equal height. Ah, yeah, it works. Yeah. I mean, of course it works. It's so logical. But maybe we can actually get rid of this and do it like this. I mean, it works, right? If it doesn't, we can just go back. Okay, let's check one more time. Come on. Yeah, it works. Okay, yeah, let's keep it like that. Now we only have to implement a way to detect whether we go to the top or the bottom. And I think we can do that by, or position 2 is smaller than 0, or position 2 is equal to width. Okay, let's try one more time. Maybe this works. Come on. It works! Oh my god, it actually works! So wait, okay. So what we can do now is actually, we get a loss when we go top, we just saw that. We get a loss when we go to the right, we just saw that, right? We get a loss when we hit the left, we already tested that before, and we get a loss when we go to... It works! Oh my god, this is really cool. Oh my god, this is actually exciting. Holy crap. This is so cool. So yeah, after a long time of not just trying out to refresh the screen, which actually worked, I actually managed to implement a functioning collision detection with the borders, which is insane to me. Like, just achieving that, I think you heard that from the video, it felt really great to me. And it motivated me to keep on going. But this is not the only thing that was complicated, because just look for yourself. Okay, I'm back. So now what I did is I changed the snake to this symbol here, and I changed the field to a bullet point. And wait, let's actually make this a bit smaller for now. And if we now start the program, yeah, you see it looks like this. Also I changed the sleep timer a little bit. I changed the sleep timer a little bit so the game is a bit quicker. And I also just noticed, maybe if we put this below it, there is not this like input lag between. So it first gives us, it first stops and then it gives us the "you lost" scene. Let's clear, let's start. And yeah, it works better. Okay, it's just a minor thing, but okay. Besides that, actually, we have to probably... Okay, no, this is fine. This also looks like, as I said, less rectangular now. It looks like a square. We have a good symbol, and we use these bullet points, the small bullet points, and I will probably use a medium-sized bullet points for the food that makes the snake bigger. And talking about it, how do we get bullets inside, or the food inside of our field? Basically, we should probably find a way to randomly place one anywhere. Once we are done placing something randomly, we need another detection, another like collision detection with the food that we placed. How do we do that? How do we import something randomly? Isn't like randomness something that hasn't been figured out yet? Okay, I think it's time for more research. I'll be right back. And then I did do some research, and it was actually pretty easy to find an answer for the question I've been having, because I was just checking for modules that were random or random modules, and something popped up immediately. Was actually quite easy to understand, because I have already went through the troubles of finding modules when I was actually working on clearing the terminals. So because I have already acquired the skill of looking for modules, I don't want to sound arrogant or anything, but this time looking for another module was actually much easier. So we import randomness, and by randomness we can, or by random we can actually create positions that randomly spawn the food, which we will later put into our for loop here. So basically, let's call it food X and food Y for the coordinates, and they equal to random dot rand int here, which basically takes two arguments, which are the position that we have within the field. So let's say we take the position 0, and then we take the position 2, which should be the height of our field. So basically comment this for a second. So yeah, as we see, 0 are the index, as an index are basically the edges. And in this case, the height here should be the outer edge, the very outer edge. I mean, we could also put in 15, but I think that's not such a clean idea, because we might change the size of it and then we need to change this. Let's just do it by the variable. So yeah, let's try to do it like this, and then random for food y dot rand int, and we set that to 0 and width this time. Okay, so now we have the coordinates set. So right now the program actually sets something on the coordinates, and it kind of is not showing for us right now. Yeah, it's not showing for us right now because we still need to print it or show it in the field. What we need to do basically is probably get this, like put it right here. Let's change this to elif and say that the position X equals to food X, and the position I equals to food Y. And then the field, okay, I mean, we can just try it like that. And yeah, it works. Here, something is randomly imported. Okay, okay, that's fine. That's very good. Okay, let's try again. And it's somewhere else. Yeah, that's great. It works. Yeah, this is nice. Okay, now we need to create another collision detection. And if we are on the same field as the food, let's first make the food disappear and let it spawn somewhere else. Okay, maybe we can change the symbol of the food. Okay, I found something. We can use this. Okay, it looks a bit too big, you know, that it like distorts everything. Okay, why is there nothing right now? Okay, this is weird. Wait. Okay, now it works. I mean, did I just not see it? Wait, or am I tripping? Let's put this to F for food. Just 1 second. And yeah, it's being printed. It's fine. It's like totally okay. So maybe there was a problem with the symbol. Wait, let me try again. Change this to this. Huh? I mean, it works, so who gives a shit at this point? It kind of works. Not kind of, it does work. And yeah, it's being imported, right? Let's first implement a collision detection that when we collide with it, it first of all prints a statement and tells us that it's collided. Let's do that. Let's try it like this. We put in another if statement. If position 1 is equal to food and equal to food X, and position 2 is equal to food Y, let's print 8. Let's save it like that. This should now, yeah, as you can see, it works. I mean, it's getting flicked away instantly, but we can see it maybe a bit better if we set this timer to 3 again. Of course, it spawns at the very end when I decide to make it slow. Yeah, it did work. Okay, yeah, it does. It 100% works. Okay, so the unit collision is actually working fine. Set the speed back before I forget about it. And now we have to initiate a new randomness and delete it. What if we put another if statement here and put the unit collision here? Let's take this away because we know that this collision is working. Let's put this like this. Let's say field is equal to this again. Does this work? I mean, it does overlap, but it doesn't really do anything else besides that. Oh wait, we can maybe do it like this. Can try to take this away. If we collide. Okay, now it doesn't work anymore. Okay, no, this is not the angle to go, I think. Maybe. What if put another elif statement where we put in the, let me copy my collision. I'm too lazy to do that again. Position 1 equals to food X and position 2 equals to food Y. The field should become the normal field, which means that it should become this. Right? Don't spawn on the edge, I suck too much. Okay, no, it's getting reprinted. Okay, maybe the collision is working, but there is no logic right now that actually tells the program to remove it from this position. How can we fix that? Okay, wait, let me save this collision somewhere. Like, let's comment it out. Let's delete this. Let's delete this. Let's comment it away. So basically the logic is we have an import and this gets imported into the field. This randomly picks a coordinate and this here places the thing on the coordinate. Maybe I need to find a way to change this again. What if we just do it like this? We set the variables food X, food y to food x food y. Shouldn't this create a new random coordinate for the thing to spawn in the next frame? I think it should, right? No, it doesn't. But it makes the screen flicker. Can you see that? I mean, I've done something, but not the correct thing apparently. Okay, so in my mind, maybe the collision is... I mean, the collision is working. Like, there is something that is colliding actually, because as you can see, something happens to the screen the moment we hit the thing. It blacks out for a frame longer. It's probably not so easy to see because it flickers anyways all the time. But is it not randomly initiating a new random sequence? What if we just take this and put it like this instead? We initiated completely new. We set the variable to a different thing, to a different coordinate. Maybe this works. Wait, actually, maybe this might actually work. Yeah, it works! Oh my god, it actually works! Oh my god! Oh my god, this is so cool. Oh my god, this is so cool. Holy crap. Okay. Holy crap. It actually works. Okay, now nothing spawned. Again, nothing spawned. Is it maybe because it's getting... Ah, wait. What if we do it like this? -1? With -1. I think this maybe could fix the problem we've been having. No, it doesn't. It still spawns on the edges. I mean, it's fine as long as it doesn't spawn outside of the edges. Okay, it still does spawn outside of the edges. Why could it spawn outside of the edges? What's going on here? Ah, wait. Here, because maybe it's this? Because we create the randomness new? Okay. I need to test it just a couple of times to make sure that it doesn't spawn outside of the edges. I mean, it spawns on the edges a lot. Why is that? It hasn't spawned in... I mean, it's still outside or not being printed at all. I mean, maybe it's not outside at all. Okay, I think it's because if we go here to 15, is it because it spawns outside and I have to do the same thing as I did here by adding -1 and -1. And then if I start, maybe it doesn't spawn outside anymore. And so far, so good. Yeah, so far so good. It doesn't spawn outside anymore. Yeah, okay, I think it's fixed. I think that was the issue, actually. I mean, I'm not sure how to check it, and I still would prefer it if it wouldn't spawn on the edges, but let's not make the game too easy. I mean, the fact that it spawns outside so much is probably due to how the random module works, right? Because it really is spawning outside quite a lot. But I'm not going to complain about that because I'm actually happy that the thing works the way it does right now. Yeah, I mean, it works. It doesn't spawn outside anymore. Yeah, that's nice. That's very nice. Very nice. Very nice. I like it. It's actually, I can't believe this is actually, I made this. I made this. This is so insane. Okay, now we need to maybe fix before we add something else. Let's fix that we can't go into the same direction that we came from. I'm skipping forward just a little bit because this next part actually took me over 1.5 hours and I was barely talking in it, so here you go. Okay, wait, I have an idea. I know I had like 5 million ideas right now, but maybe this is the actual idea that I'm having here. Let's put this, let's indentate this, let's copy it, and let's put it here. Let's take these out, okay. We just set the move to, or the move to here. We don't do any actual movements here, so that the movement only happens here. Okay, let's put this, all of this one back. This should work. I think in my head this makes sense. Okay, we take these away. this is basically the move. We can take these away. Okay, like this, I think. No, we have to change this to move. Okay, so now if we go to move to, which is an input here, equals to D and not A, then move is set to move to, but only if this condition is met. So if it's D and not A, then the move is move to, which means that this, we have to take these one back as well, one indentation back, which means that only then the value gets changed. So only then move is set to move to. Then the move variable here actually changes the position of the thing. Maybe this works. Okay, we can go. It works! Oh my god, it works. I can't go to the direction that I'm coming from. Yeah, I can't go into the direction I'm coming from. It actually works. No, it works. Oh my god, this took me a lot longer than I actually anticipated. Holy sh*. But it works. This is so nice. I really, really enjoy this. I'm really, really proud of myself. Okay, let's change the speed back and let's just try it one more time. Because why not? Yep, it works. And I can't go into the direction I came from, but I can go anywhere else. Okay, nice. So now the only things that we need to do is to actually increase the size whenever this collision condition is met, and then we have to move the entire snake to the front. At this point, I had a moving character, I had food that spawns randomly, and I had basic collision detection. But I had one bigger problem. My snake was still only one symbol, and I've spent hours trying to figure out how to solve that issue at this point. But I thought that I might be lacking a fundamental idea. I already had a good mechanic in mind how to actually make the snake move. I thought that whenever I spawn a new symbol, instead of moving the entire snake to the direction we're facing, I just want to move the last symbol into the direction that we're actually facing. By doing that, I only had to move one symbol at a time and not the entire thing at the time. But I couldn't do that. So I took a break, and with a fresh mind on the next day, I found out about lists. When the snake eats food, I want it to grow. My first idea was to just increase the number like a snake length variable maybe, but then I figured out that it's only telling me how long the snake should be. I could print the value into the console, but it didn't actually print the snake into the grids that we have created before. So I learned that this is exactly what lists are useful for. A list can store multiple values in one single variable. For example, instead of only storing one position like this, it can store the snake as a list of positions like this. At first it looked weird to me because it's a list inside of another list, but the idea is actually pretty simple. The outer list represents the whole snake. The inner list represents only one part of the snake. So this means that the snake is currently only one body part, and that the body part is at X position 1 and Y position 1. If the snake grows, the list could look like this. This means the snake has 3 parts. The first part is the head, the next part are the body parts. The reason this worked so well is that the snake basically moves by shifting its body forward. Instead of moving every single part manually, I can do it by just the simple idea that I explained before. First, I calculate where the new head should be. Then I add the new head to the front of the list. The 0 means that the new position is inserted at the beginning of the list. So if my snake is this and the new head is this, then after inserting it, the list becomes this. Now the snake becomes one part longer. But if the snake did not eat any food, it should not grow every step. So I removed the last part of the list. This removed the tail. And this creates the movement. The new head appears in front and the last body part disappears. Visually, it looks like the snake is moving forward one step. If the snake eats food, I simply do not remove the last part. That means the new head is added, but the tail stays. This makes the snake one part longer. So the main logic is this: add the new head and remove the tail if no food was eaten. I needed a way to remember multiple positions at the same time, and the list gives me exactly that. And if we put it all into practice, it kind of looks like this. So yeah, I've been playing around, and as I mentioned about the functionality of the lists, which basically create the snake, make the head pop up in the first position, and removing the last one that we had, it actually looks beautiful. I also fixed the time to 0.15 because it felt a bit more fluent to me. And yeah, let's check it out. And as you can see, it's actually working super well. I love this. I have done this. I've been coding for a little longer than a week now, and I have actually created this. This is insane. As you can see, it's still not perfect. I mean, it's flickering and everything, but that's not the point. What I mean is there are still 2 issues, one of which I still want to resolve. The first issue being that sometimes the food can spawn inside the snake. I have no logic implemented that prevents that from happening, but I think it's totally fine. Like, I'm still going to have this. But the one thing that I want to fix is that when I move through my own snake, it should end the game. As of now, it's not doing that, but I already have an idea how I could potentially do that. So yeah, let's get to it. What I thought is that in the end, we have a unit collection detection with itself. So basically that if the head of the snake actually touches itself, then it also, or touches the length of the snake, the while loop should also be set to false, or the run variable that runs the while loop should be set to false. So what I thought we could do is maybe something like this. For I, we do another for loop for I in range. And then as a range we take 1 because we don't want to start at the index 0, which is the head itself. And then in the length of the snake, we could check if the snake, or if I in this case, it should be I, in the list is equal to snake and the index of the head. If that's the case, we just set run to false. And we could print something like, you just ate yourself. Okay. Let's see if this is working. You know what? Let me do something. For testing purposes, let's make this a lot smaller. Let's do it like 10. Let's save it and let's run again. It works! Yeah, it works! It collected. You just ate yourself. It works, it works, it works, it works. Oh my god, I'm so hyped. This is actually so... Oh my god, no, this is amazing. For now, I will call this a success. I will call this a big freaking success. Because not only do we have a working game that like you can actually play, but also I have learned a lot of concepts that actually I didn't know about before. So what I now have is I know about lists. I know about modules. I know how to create inputs without stopping the program. And this is, in my book, this is insane. This is incredible. I figured out how to have collision detection. And all in all, this looks beautiful. This looks incredible. Yeah, there you have it, guys. I just built Snake. I got myself a working game. This is amazing. I'm super, super happy with the results. And yeah, that about sums up my experience. And if you were actually listening to the very end or watching to the very end, thank you so much. And I hope I see you in the next video until I get employed.